Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on today's lesson, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. Today, we're going to begin the second half of the unit. We're looking at Unit 6, Introduction to Quadratic Functions, Lesson 11, Graphing from the Factored Form. The learning goal today says let's graph some quadratic functions in factored form. We have two learning targets today. As we go through the practice problems, keep these at the front of your mind because these are the skills you're going to need to know for the test. At the end of the lesson, we'll come back and review them and ensure you've learned everything you need to be prepared as we move forward. Learning target number 1 says that you can graph a quadratic function given in factored form. Learning target number 2 says that you know how to find the vertex and the y-intercept of the graph of a quadratic function in factored form without graphing it first. Now we can begin the practice problems for Lesson 11. Select all true statements about the graph that represents y equals 2x times the quantity x minus 11. So, what I want you to notice anytime that we have a long list of multiple choice here is that if you read through all of them, you'll notice that choices A, B, C, and D all talk about the x-intercept. And then you can notice that choices E, F, G, and H are all talking about the vertex. So if I look, A, B, C, and D, A, B, and C are giving you two possible coordinates for the x-intercepts, and D is saying that there is only one x-intercept. So only one of these choices could be true. Then if I look at E, F, G, and H, they are all giving you a possible different coordinate for the vertex. So only one of these could possibly be true. Now it's our job to decide which is which. If we want to find the x-intercepts, what we're going to do is set each factor equal to 0. And this is because if I am on the x-axis, then my y value is always 0. So that means I'm going to take the first factor, which is 2x, and I'm going to set that equal to 0. The opposite of multiplying by 2 is dividing by 2. But I need to do that to both sides. Now 0 divided by anything equals 0. So my first x-intercept is going to be at the point 0, 0, which is the origin. The next thing I'm going to do is I'm going to take my second factor, x minus 11, and I'm going to set that equal to 0. The opposite of subtracting 11 is adding 11, but I need to do it to both sides to keep it equal. I now get the answer that x equals 11, so my second x-intercept is going to be at the coordinate 11, 0. So now I know that my first one is at the origin 0, 0. I know that my second one is at the point 11, 0. That matches choice B. So B is the correct answer out of the top group. Now, if we look at choices E, F, G, and H, we are trying to find the vertex. And what we're really looking for is the x coordinate. And one thing to know about parabolas is that they move away from the vertex in both directions at the same rate. So this means it will be halfway between the x-intercepts. So, if I know that one of my x-intercepts is at 0, and I know my other x-intercept is at 11, I can add these together and divide by 2. So that's going to give me 11 divided by 2, which equals 5.5. So that means choice H is the correct x-coordinate for the vertex at 5.5. If you have any questions about how to find the x-intercepts or how to find the x-coordinate of the vertex when they give you the factored form of the quadratic equation, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2. Select all equations whose graphs have a vertex with an x-coordinate of 2. So if I want to find the vertex, this means I need to find the x-intercepts and then divide them by 2. So, for choice A, if I have x minus 2, set that equal to 0, add 2 to both sides, and I get x equals 2. Then I'm going to take x minus 4, set that equal to 0, add 4 to both sides, and I get x equals 4. To find my vertex, I'm going to add 2 plus 4 and divide it by 2. 2 plus 4 is 6, and 6 divided by 2 is 3. So the vertex would be at 3, not 2, So A is incorrect. Now that we look at B, we can notice we already solved the x-intercept for the factor x minus 2. So I'm just going to bring this down, and that's one of my x-intercepts. For the other one, I'm going to set x plus 2 equal to 0. I'm going to subtract 2 from both sides, and I find out that x equals negative 2. To find my vertex, I'm going to say 2 plus negative 2 divided by 2. 2 plus negative 2 is just 2 minus 2, which is 0. And 0 divided by anything is 0. So the vertex here would be at 0, not at 2. So B is also incorrect. Choice C. We're going to set x minus 1 equal to 0. Add 1 to both sides, and we get x equals 1. Now we're going to set x minus 3 equal to 0. Add 3 to both sides, and we get x equals 3. So the vertex is going to be at 1 plus 3 divided by 2. 1 plus 3 is 4. And 4 divided by 2 is 2. That's what we were looking for, a vertex with the x-coordinate of 2. So C is a correct choice. Choice D. First, we're going to set x equal to 0. So that's one x-intercept. Next, we'll set x plus 4 equal to 0. Subtract 4 from both sides, and that'll give us x equals negative 4. To find the vertex, we're going to add 0 and negative 4 and divide it by 2. This becomes 0 minus 4 divided by 2, which is negative 4 divided by 2, which is negative 2. We did not want the vertex to be at negative 2. We wanted it to be at positive 2. So D is incorrect. And for choice E, we set x equal to 0. That gives us one of our answers. We set x minus 4 equal to 0. We add 4 to both sides. That gives us x equals 4. So my vertex is 0 plus 4 divided by 2, which is 4 divided by 2, and that gives us a vertex at 2, which is what we were looking for. So E is also a correct answer. So choice C and choice E both have x-coordinate vertexes at 2. If you have any questions about how to use the factored form of a quadratic equation to find the x-coordinate of its vertex, Please leave a comment below, and I'll get back to you with any help that I can offer. Our next practice problem says determine the x-intercepts and the x-coordinate of the vertex of the graph that represents each equation. So, to find my x-intercept, I need to set each factor equal to 0 and solve for x. So, in the first one, that means we need to set x equal to 0. So I have an x-intercept at 0, 0. Then I need to set x minus 2 equal to 0. I add 2 to both sides, and now I have x equals 2. That means my other x-intercept is at 2, 0. To find the x-coordinate of the vertex, I need to add these together and divide by 2. So 0 plus 2 divided by 2 equals 2 divided by 2, which is 1. So the x-coordinate of the vertex is x equals 1. Now for the second one, we have x minus 4 equals 0. We're going to add 4 to both sides. And that gives us x equals 4. So the first x-intercept is at 4, 0. Next, we have x plus 5 equals 0. We're going to subtract 5 from both sides, and this gives us x equals negative 5. So our other x-intercept is at negative 5, 0. Now that we know the x-intercepts, we can add them together. So we have 4 plus negative 5, and we divide it by 2. Well, this becomes 4 minus 5 divided by 2, which is negative 1/2. So that means the x-coordinate of the vertex is going to be x equals negative 1/2. And lastly, we can set negative 5x equal to 0. We divide both sides by negative 5. And 0 divided by anything is 0. So we know that our first x-intercept is at the origin 0, 0. Next, we set 3 minus x equal to 0. We add x to both sides. And this gives us 3 equals x. So we know that our other x-intercept is at the point 3, 0. Now we can add these together, 0 plus 3, and divide by 2, which is 3 divided by 2, which is 1.5. So we know that the x-coordinate of the vertex is at x equals 1 and 1/2. If you have any questions about how to use a factored form quadratic equation to find the x-intercepts and the x-coordinate of the vertex, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 4. Which one is the graph of the equation y equals x minus 3 times x plus 5? So first, let's find the x-intercepts. We'll take x minus 3 and we'll set it equal to 0. We add 3 to both sides, and we find that x equals 3, so we have an x-intercept at 3, 0. So it cannot be graph A. It could be graph B. It could be graph C. And it cannot be graph D. So now let's find the other x-intercept. We need to set x plus 5 equal to 0. We subtract 5 from both sides, and we see that x equals negative 5. That means the other x-intercept is at negative 5, 0. So now we know that it could not be graph B. It must be graph C. That is the only graph that has both of the correct x-intercepts. So we know that the correct choice is C. If we had needed to, the next step would have been to find the x-coordinate of the vertex. If you have any questions about how to take a factored form quadratic equation and match it to the correct graph, please leave a comment below and I'll get back to you with any help that I can offer. Our last practice problem, number 1, asks us, what are the x-intercepts of the graph of y equals x minus 2 times x minus 4? So let's find the x-intercepts by setting each factor equal to 0. So we have x minus 2 equals 0. We add 2 to both sides, and we get x equals 2. So we have an x-intercept at the point 2, 0. Now, we can set the other factor, x minus 4, equal to 0. We add 4 to both sides, and that gives us x equals 4, so the other x-intercept is at the point 4, 0. So our answer would be 2, 0, and 4, 0. Number 2. Find the coordinates of another point on the graph and show our reasoning. So for number 2, I'm going to find the vertex. I'm going to take the two x-intercepts, 2 and 4, add them together, and divide by 2. That gives us 6 divided by 2, which is 3. But 3 is my x. Now I'm going to substitute this 3 into the equation to solve for my y value. So y equals 3 minus 2 times 3 minus 4. That means y equals 1 times negative 1, which means y equals negative 1. So my vertex is at the point 3, negative 1. And lastly, number 3 wants us to sketch a graph. So I will draw a coordinate plane. I can see from these points that my biggest value is going to be 4. So I'm going to number to 5 in every direction. So first I need to put an x-intercept at 2, 0. So I go over to the right 2, and then I don't go up or down. Next, I need an x-intercept at 4, 0. So I go over to the right 4 and up or down 0. And then my last point would be my vertex at 3, negative 1. So I go over right 3, down 1, and I put my vertex. And now I could draw my parabola, connecting them and continuing in both directions. So that is how we would sketch the graph. If you have any questions about anything we've gone over in the practice problems for Lesson 11, please leave a comment below, and I'll get back to you with any help that I can offer. Now, before we end the lesson, let's go back and review the learning targets and make sure you understand everything you need to as we move forward into the next lesson. Learning target number 1 says that you can graph a quadratic function given in factored form. To graph the parabola for a quadratic function, you need 3 points. 2 points could possibly be your x-intercepts if the parabola has 2 x-intercepts. Find those by setting each factor equal to 0 and solving for x. Another point is the vertex. If you have 2 x-intercepts, you can add them together and divide by 2 to find the x value of your vertex. Substitute that x value into your original equation and solve for the y-coordinate of your vertex. Once you know the x and y coordinates of the vertex, you can plot it for another point. Another point that you could possibly solve for is your y-intercept. If you're on the y-axis, then your x value must be 0. You can substitute 0 into the original equation for x and solve for y to find your y-intercept. Between these 3 choices, you should be able to find 3 points. Either 2 x-intercepts and the vertex or the y-intercept, or 1 x-intercept and the vertex and a y-intercept. Learning target number 2 says that you know how to find the vertex and the y-intercept of the graph of a quadratic function in factored form without graphing it first. Again, if I want to find the vertex, I need to find my x-intercepts, add them together, and divide by 2 to find the x-coordinate, then substitute that x-coordinate into the equation to solve for the y-coordinate. If I want to find the y-intercept, then being on the y-axis means my x value must be 0. I substitute 0 in for x on the original equation to find the y-intercept. If you have any questions, please be sure to leave a comment below. On the screen, you should see another video that YouTube believes you will find helpful. I ask that you please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.